When it comes to me, it's like I'm working in giving trainings in machine learning, right now mostly in deep learning. And just I'm curious, one short question. How many of you have ever trained a neural network? Oh, it's like most of you. So maybe this one will be very, very simple, maybe even too simple for you. Because here the idea is that it's not hard. So basically, this is the most cliche meme when it comes to deep learning. But, well, every of us is, well, somewhere there, right? Here, or here. And this time I want to talk about this part, just instead of piano, about Keras. That it's that simple. Except that you need to add a few more lines of code. When it comes to deep learning, I'm still impressed by its progress. Each month there is something new. One of the recent things I saw when it comes to image processing is this image colorization. So an algorithm which takes a picture in grayscale and gives an output of a colorful picture. And sometimes it's hard to guess if it's a result of a neural network or if it is an actual real picture. And it's happening in many other areas related to image recognition and also, well, and not only. But I don't want to give an introduction to deep learning because it's a short talk and it's very hard to squeeze all of its material into this spot. But I want to show one tool. A tool which is that simple that just you can start right away with a few lines of code, and then by learning deep learning, you can expand it, you can add more layers, you can make some changes. When it comes to Keras, it's a library that is something like Python for deep learning. So something which is very simple, very concise, and also high level. So it's not a library for any optimization of tensors and matrices like TensorFlow or Theano, but just focuses on neural networks. The good thing is that it makes it very easy to write code and also to read code. By the way, when it comes to its names, like just I didn't know it's like if it's Keras or something. So just don't confuse it, for example, with Karaś. So just sometimes I use it. I use this name. So why Keras? One thing is that it's easy. And as in Python, it's important not easy to. It's not only important that it's easy to write, but also that it's easy to read. So if I see some other code, I can read it, I can reason about it, and I can use it. Also, the fact that it's popular is important for example, blog post. So if we can learn about some new technique, or if there is some repository with implementation of something in Keras, and more than often, if it's something rather mainstream, I can Google something in Keras, and there is some code, usually very simple, and usually ready to use. Again, it's in constant development, and I found this documentation rather good. Not only as a documentation for its API, but in general as some very, very soft and simple introduction to neural networks. There is a plot about deep learning frameworks and their growth. There's some custom formula based on GitHub stars, issues, other signs of GitHub activity. And on the first place there is TensorFlow, and on the second there is Keras, which can run on top of TensorFlow or Theano. Of course, you might say that one thing, that popularity is not the same thing as quality. It's true. And the second thing, you might say that this plot was prepared by the author of Keras. So I guess this formula is a bit tweaked to make it very high. Well, but the thing is that this is more or less a landscape of various frameworks, and of course popularity is one of measures to go, but there is a reason why Keras is popular, and usually it's simplicity. And of course there are tasks for which Keras may be not optimal, for example very custom neural networks and some research level neural networks. But for example, when I teach deep learning, and I do it both on corporate workshops and when volunteering for very smart high school students, I usually start with Keras. Why? Because for me it's the simplest way to approach it. You can start from, well, coding things in C or even assembly, but usually it's not the easiest way to teach someone programming. Usually things like Python or something high level, maybe a good introduction. And here the same thing holds for neural networks, especially when there is like a short time. So for example, usually companies want to learn everything about deep learning in 2 days. So okay, so it may be hard, but still it gives me the best shot. But this way I can, because sometimes well, they want something different. So just to show, I'm just curious, how many of you have ever used Keras? Okay, not everyone, because if you have ever used Keras, then it's going to be boring, except for 1 or 2 libraries. I'll show you later. So here is the most boring part. And be careful, because you run code right now on the computer, so if anything crashes, well, it will be the end of this talk. Okay, so, well, it should work. So when it comes to logging data, it has even some built-in data downloaders for a few sets like NIST or CIFAR. And we still need to pre-process it a bit. For example, change its shape. So to make an image from a vector, a specified number of channels, here is just 1 because it's just grayscale. For example, if it were a picture with RGB scale, it would be like 3 channels. Sometimes we use more channels, for example, for other input. We need to scale things to floats and so that they fit in 0-1 range. And then we change answers from numbers like answer is 1 to 5 to probabilities. So like all zeros and 1 1. And so its shape, it's how many instances, resolution, number of channels. And for answers, it looks more or less like that. So all zeros and 1. Because it's the thing we want to compare with a neural network, probabilities, not only results. If you want to see what's in data, then also I like a lot package called Seaborn, which most of you may know. I can see, okay, 2. Okay, so 2 is like that. It's one of many instances of 2, just to get some insight what's hidden in this data set. Well, but let's go to Keras. So with Keras, the simplest way to go is to start with sequential models. So you basically stack layers on each other, like if you were cooking a lasagna, though lasagna is also a name for another package, unrelated. But I think this analogy is very good, in the sense that when it comes to creating neural networks, there are some rule of thumbs. But if we add more of it, a bit different, sometimes it's also a matter of experience and trial and error. Rarely it's like, well, someone can just look at problem, say, okay, it requires exactly 8 layers, this one and that one. It never works that way. So import layers you want to use. I will show them later. Should work. And for example, the simplest model you can do is logistic regression. So basically, something is very shallow, very classical machine learning, or even classical statistics, but still we can do it. So we can read data, we change this image back to just a vector, we create everything, so basically it's a matrix, like if in logistic regression, and then we apply softmax, so this generalization of this logistic, and it's 5 years old library for making some cooler progress bars. Okay, I know it's maybe just it's for aesthetics, but sometimes I do like aesthetics. So we can train it with such error progress bar, much more, well, up to date. What's more important is to look at its performance, and there's an easy way to plot its performance. So accuracy going with epochs, and usually this accuracy on the dataset on which we train is higher than the one on the validation dataset. So here we need to be very careful not to overfeed it to our training dataset, but also but to make it with as strong predictive power as possible. Okay, but it was just logistic regression. If you want to go any deeper, well, we need to start using convolutions, at least for image processing. A convolution is a simple thing which basically takes each collection of pixels, multiplies them by some values, and then creates a new layer, modified layer with this filter. We can use it to detect edges, to detect color changes, to detect average intensity. Here it's very simple because it is a very small filter, but we can make it much larger so it can detect bigger patterns, and more importantly, you can stack convolutions on each other. So for example, there is one convolution that just detects edges, and then the next one looks at collections of edges at some various angles, so it can detect, for example, curves, or can detect circles. So if you want to train a neural network with convolutions, just we add layers for convolution. So for example, here we need to specify convolution size. By default, usually we use 3 by 3, just many of them. And one more thing is the number of channels. Number of channels is basically how many different convolution results you want to keep. Because usually it's not like you want to detect edges, but the edges, horizontal edges, and a few other things. And especially at higher levels, we want to discover many patterns at the same time. And then it's like activation, some nonlinear function, and the size reduction, which is very important for building bigger neural networks. Again, flatten because we want to have it flat. Everything, softmax. If we create it, again, we can look at the structure. This time, first we saw that there is some picture, then there is a bit smaller because of some edge effects, but more channels. Then we reduce its size, and then in the last step we flatten it and perform logistic regression on the last layer. And again, we can train it exactly the same way. It will take longer because the more layers we add, it requires more operations, and also very often it means that there are more parameters. So maybe just maybe I won't skip it, but at the same time, just it requires some patience. And also, it's one of arguments why we need to have a stronger computer with a GPU, because it's a very small data set, very small, very simple, and sometimes, well, there are huge pictures, for example, for recognizing blocks or roads from satellite images, and also we want to make it as accurate as possible, not just something which works better than random chance. So we are almost there. One epoch. Oh, okay, so usually it's not like the use case not to look at progress bars for a long time, but usually just but such things sometimes can take overnight or over a weekend, or we can work on some other problem while it advances. Again, we can look at how it goes. So now it actually accuracy is much higher. It was like 92, now it's 97%, just by adding one convolution layer. If you add more of them, sometimes we can get better. There are more layers for correcting for errors, like dropout layer, and you can stack much more convolution layers. And just to show you that it's also easy to express some real deep learning network, so not like a small one, but one which wants some competition or is used as some default reference. This is VGG16 in Keras. Okay, it takes some time, some number of lines, but each line is a single layer. So it's not like that it requires a lot of boilerplate, it's not like it requires a lot of visual noise. Just we exactly write what we want. We can use it for prediction, we can use it for training. And just to give you some, maybe I want to add more layers, just I commented it just in case, I can make some additions. Okay, maybe I can do it in the background to add more layers. Actually, I know, but maybe just drop out. Okay, I add some more layers, I can see what happens there. So see, you have more layers, you have different combinations of weights at various stages. This one will be much less prone to overfitting, for example. You can do it in background. Usually, again, you need to use more epochs than 5, just for the sake of this lecture. It's 5. So, but when it comes to other cool stuff we can do with Keras. Okay, the thing I discovered yesterday, like these progress bars, it turns out that it's also possible to run it in a browser. So someone wrote something converting Keras weights to some other, I think, Andris Karpaty's JavaScript implementation of neural networks. So you can run deep learning network in a browser. And it has GPU support, even for cards not supporting CUDA. Why? Because it uses browser support of GPU. There's something like interesting tool for looking at weights and then looking at what happens with an image when it goes through a layer, and then like each layer, and then some small library I wrote. And of course, if you want to learn more about deep learning, it's not enough to learn Keras API. It's much more complicated. But there are many materials, and when it comes to ones I like the most and consider they are the easiest start, there's a collection of them. So just I will share this list with you after this talk. So if you're interested, maybe something will be useful for you. Okay, so basically it's that. I didn't want to dive too deep or too difficult into Keras. And if you have any questions about Keras, about deep learning, or about workshops at your company, then I'm very, very happy to answer. So thank you.
Any questions?
This will be a short one. Is that notebook available for download?
Yes, just I need to update it and I will send a link to it.
Alright, thank you.
Just after this meeting.
Okay. Any more questions?
Hi, what kind of neural networks from the deep learning side will be the best for the time series?
For time series, usually, okay, a bit depends, but at least either there are one-dimensional convolutions, so also for looking for patterns, but 1D, for some of them, but usually it's some long-term memory networks, some recurrent neural networks, and also Keras support them.
Just out of curiosity, if there is a way to just reduce the boilerplate in one code snippet, I'm just coming from Ruby world, and when I see boilerplate, I can just use metaprogramming. Is something like that possible in Python?
But I don't know much about metaprogramming in Python. I guess there isn't much of it, or there is, but I'm not aware of it. So, but which particular type of boilerplate do you want to remove?
These huge declarations, you just talked about additional layers, and then you just show a large code snippet
yes.
About large amount of declarations and so on.
Okay, so well, this thing is usually you have a file which defines this function. You usually you don't need to copy and paste it over and over. It's just a function. So for that you don't need any metaprogramming except for defining a function.
Okay, cool. Thank you.
Any more questions to our guest? Nope, not yet.
Okay.
Okay, are you going to join our after party?
Yes.
Okay, so you have a chance to talk to Piotr during after party, and right now, thank you so much.
So thank you.